So what I want you to do is, this is a ring. Okay, imagine this is a ring. It's a metal ring. And so you're looking down on the level surface at a ring. And the ring can move in either direction, x and y, on the horizontal surface. There's three forces acting on the ring. First one is downward. Call it force 1. And it has a value of 6 newtons. Okay, the second force goes off to the right, F2, and it has a value of 5 newtons. And then the third force acts upward, and it has a value of 3 newtons. Okay. Now, if I asked you to find the net force on that ring, well, let's just say, what direction is the ring going to accelerate? Give me an idea, point. Is that way, or that way?
Southeast.
Down this way, right? Because most of the force is going off this way, right? So we're going to be somewhere in here, right? Intuitively, we know that. We're going to be somewhere in there. But just saying that's not enough for us, right? We want to be able to say exactly how much force in the exact direction. Okay. Now, the last 2 days or 3 days when we're looking at adding vectors, we do tip to tail, right? So I'm going to do that with these 3 vectors. So let's draw in this vector. So this vector is F1. That's 6 newtons down. Remember, to add vectors, you do tip to tail. So the next one is F2. So at the tip, put the tail, go over 5 newtons. And then to that one, you put the next one, F3, tip to tail, 3 newtons. So those are our 3 vectors added tip to tail. And then we draw in our resultant. There it is. That is that, right? It's the same line. So intuitively, you knew that. Now we're doing it tip to tail to actually calculate the numbers. So now this resultant triangle can be thought of as the sum of its x and its y components. So what is the x component of the resultant triangle? 5. And what is the y component of the resultant triangle? 3, right? So basically we have a triangle that's 5 that way and 3 that way. So 5 and 3, we want to get the magnitude of the resultant. So you would do the Pythagorean theorem. 5 squared plus 3 squared is square root of 34. Is 5.8. So the magnitude is 5.8. And then you need to get a direction. So here's theta. So theta would be inverse tan 3 over 5. And you get 31 degrees. So that's 31 degrees. So basically what we found is that this is 5. And this is 3. This is 5.8. That's 31 degrees. But do you guys see how I didn't need to redraw these as tip to tail? I could have not even done this, right? And just knowing that these are going to result in one triangle, I would say the total force in the x direction is 5. And the total force in the y direction is 3 plus what? Negative 6, which is negative 3. 5, negative 3. And then you can do your triangle and get your resultant. So my net force is 5.8 newtons, 31 degrees below the positive x-axis. So I didn't even need to do any of this. I could just do it that way. You guys see that? It's the same thing. It's actually a little easier, right? Not. But we wanted to build the skill of using components, and we do that with the displacements.